Good day everyone. In this video, I am going to discuss to you about triple integrals in spherical coordinates. But before that, let me introduce to you our objective for this day. Our objective for this day is that at the end of the discussion, the student can be able to know the triple integral in spherical coordinates formula and evaluate triple integral in spherical coordinates. In a spherical coordinate system, a point P in space is represented by an ordered tripole rho theta phi, where rho is the distance between the point and the origin, as you can see here in green. Theta is angle counterclockwise from the pole or positive x-axis, as you can see here in blue. Phi is the angle between the positive z-axis and the point, as you can see here in red. We also need to be familiar with the equation to convert between spherical and rectangular coordinates. In converting spherical to rectangular, here is the formula. X equals rho sine phi cos sine theta. Y equals rho sine phi sine theta. Z equals rho cosine phi. When converting rectangular to spherical, rho squared equals x squared plus y squared plus z squared. Tan theta equals y over x. Cosine phi equals z over square root of x squared plus y squared plus z squared. So this formula, you need to copy this into your notes in order for you to know how to convert between spherical and rectangular coordinates. Take a look in the triple integrals using spherical coordinates. If we have a triple integral in rectangular form, as we see here, this is how we write it in spherical coordinates. There are several things that we should recognize here. First, the function must be expressed in spherical coordinates, where x is equal to rho sine phi cosine theta, y is equal to rho sine phi sine theta, and z is equal to rho cosine phi. Then notice that differential v is equal to rho squared sine phi d rho d theta. There's an extra factor of rho squared sine phi when converting to spherical coordinates. Just like any other triple integral, we can change the order of integration. Let's go and take a look at an example. Here we want to integrate our function over the solid region x squared plus y squared plus z squared is equal to 4. We should recognize this as a sphere with the radius 2. Let's go ahead and set this up. First, let's convert our function to a function in spherical coordinates. Well, x squared plus y squared plus z squared is equal to rho squared. Then, because we are converting to spherical coordinates, we have extra factors of rho squared and sine phi. Let's go ahead and keep the order of d rho d phi d theta. Let's start by taking a look at the limits of integration for rho. Remember, rho is a distance from origin to a point on the surface. Because the radius is equal to 2, the limits of integration for rho will be from 0 to 2. Next, the limits of integration for phi. Remember, phi is the angle between the positive z-axis and the points on the surface. To get the entire sphere, rho would have to be from 0 all the way to pi radians. Then for theta, the angle between the positive x-axis and the points on the surface we have to rotate all the way around a circle in the x and y plane. Theta would be from 0 all the way to 2 pi. Let's go ahead and rewrite our integrand. And then we can integrate. We have rho to the fourth sine phi d rho d phi d theta. Treating phi as a constant, we will have 1/5 rho to the fifth sine phi. Replacing rho with 2, we would have 32/5 sine phi. And then when rho is 0, this should be 0. Now we integrate with respects to phi. That's going to give us negative 32/5 cosine phi. When phi is equal to pi, cosine pi is negative 1. So positive 32/5 minus, then when phi is 0, cosine 0 is 1. So we will have a negative 32/5. We will have a positive 64/5. So we will have 64/5 theta and evaluate it at 0 and 2 pi. When theta is 2 pi, we will have 2 pi. When theta is 0, we will have 0. So we will have 128 pi fifths for this triple integral. So here another links from YouTube for you to really understand the topic. For our assessment, you can write it on a clean sheet of paper and submit it after the last reporter. So you need to integrate function f of x, y, and z equals 3e to the exponent of x squared plus y squared plus z squared raised to 3 halves over the region V inside x squared plus y squared plus z squared equals 1 in the first octet. So that would be all. Thank you and God bless everyone.